Myself Inan Alban from Maths department, and I'm going to teach you applied maths. So total there are 5 units in your syllabus. So let us start with the first chapter from the first unit, that is matrices. Now let us see the definition of a matrix. So a matrix is nothing but a rectangular array which contains number or symbols or expressions which are arranged in rows and columns. So in a matrix especially there are rows and columns, okay, and your matrix is nothing but a rectangular array. Okay, so I have taken one example where I have taken one standard matrix where there are total m rows and there are n columns. So I have denoted the row numbers, I have denoted the column numbers. Okay, so always remember your rows are horizontal while your columns are vertical. Okay, then next I have written one note here. Yes, there I have written A32. Now what does that mean? A32. Even if you see in the matrix, you can see A11, A12, I have written A13, right? So what does A11 denote? What does A12 denote? So when I am writing A11, that means the first number denotes a row number, second number denotes a column number. Like in A11, your row number is also 1, your column number is also 1. So A11 means what? The element which is present in the first row and the first column. Okay, so similarly, see, check the first row. See, the first element is A11, second element is what? A12. Why I have written A12? Because that element is present in the first row, right? So I have written A1. First number denotes the row number and it is present in the second column, so I have written 2. So that is A12. Okay. Similarly, third element will be A13 because it is present in the first row only, but it is in third column. Okay. Now similarly, see the last row, that is the mth row. Now your row number is what? M. Okay. Then if the element is present in the first column, what we write? AM1. Okay. Because that element is present in the mth row, but it is in the first column. Same thing if I want to write the element in the mth row, but in the third column. So what should I write? AM3. Where the element is present in the mth row, but it is in the third column. Understood? So in this way, you can identify the elements of the matrix. Okay, now here in the given matrix there are total m rows and there are n columns. Okay, just keep in mind your rows are always horizontal while your columns are vertical. Next is the order of a matrix. Order of a matrix is nothing but number of rows into number of columns. If I see the above matrix, so there are total m rows, there are n columns. So order of this matrix is what? M into n. Okay. Then there are types of matrices. And the other thing, order of the matrix. While writing the order of the matrix, now you will say there is multiplication. So we can write ulta also. Like if your order of the matrix is 3 into 1, so you will say 3 into 1 and 1 into 3 is same. But that is not the case in the matrices. Okay, when you are saying 3 into 1, that means there are 3 rows and there is 1 column in that matrix. But when you're saying 1 into 3, it means there is only 1 row and there are 3 columns. Okay, both are different. 3 into 1 is not same as 1 into 3. Okay, so order matters. Next we'll see types of matrices. The first one is row matrix. In a row matrix, the matrix will have only one single row and there can be any number of columns. Okay, so matrix contains one row but any number of columns. See here in this example I have taken one row but there are 3 columns. So order of this matrix is what? 1 into 3. Number of rows into number of columns. Okay, and the other thing 1 into 3 is 3. So don't write 1 into 3 equals to 3. Right? Your order of the matrix is nothing but number of rows into number of columns. So just write 1 into 3. Next is column matrix. Now in column matrix there is only one column and there can be any number of rows. Okay. Then is rectangular matrix. In a rectangular matrix, your row numbers and column numbers are different. Okay, means they are not equal. If you are taking 3 rows, then there can be 1 column, there can be 4 columns, there can be 2 columns. Okay, so they are different. Row number and column number are different. Okay, so that is rectangular matrix. But if a number of rows and number of columns are same, then we say it is a square matrix. Okay, so in a square matrix, your number of rows and number of columns are equal. Next one is diagonal matrix. So our square matrix is said to be diagonal matrix if all the non-diagonal elements are 0. Okay, so you can see the example D equals to 1 0 0 3. See, the diagonal elements are 1 and 3 and the non-diagonal elements are 0. Okay, next is trace of a matrix. Trace of a matrix is nothing but the sum of its diagonal element. Means we have to add the diagonal elements. Now if you see the example, in the example your diagonal elements are what? 1 2 and 6. Okay, so just add that numbers 1 2 and 6, so you'll get 9. So trace of the matrix is 9. Next is a null matrix. Null matrix means what? All the elements of the matrix are 0. All the elements, each and every element is 0. Okay, so that is a null matrix. Next is identity matrix. So a square matrix is said to be unit matrix or identity matrix if all the diagonal elements are 1. Okay. See, your diagonal elements are 1. Rest all non-diagonal elements are 0. Means it is somewhat type of the diagonal matrix only. But what is the difference? Your diagonal element should be compulsorily 1. Then we say it is identity matrix. Next is singular matrix and non-singular matrix. So let us see the example. I have taken one matrix A. Okay, to check whether the matrix is singular or non-singular, you have to find the determinant of the matrix. Okay, so find the determinant of matrix. If your determinant is 0, okay, then it is singular matrix. If your determinant is non-zero, then it is non-singular matrix. Okay, now see the example. A equals to 1 2 3 4. So I have taken the determinant of that matrix. Okay, so while finding the determinant, first I'm into the cross number, right? So 1 into 4, then minus 2 into 3. So 4 minus 6 is minus 2, which is non-zero. So determinant is non-zero. So that's why A is what? Non-singular matrix. Okay, I have taken one another example where your determinant is 0. Okay, so then we say matrix is singular matrix. Okay, so singular matrix if determinant is 0, non-singular matrix if your determinant is non-zero. Next is scalar matrix. Scalar matrix is also a type of a diagonal matrix only. Okay, but in scalar matrix all the diagonal elements should be same, they must be equal. Okay, so I have taken an example. In first example you can say all the diagonal elements are 2. In the second example all the diagonal elements are 4. Okay, so that is a scalar matrix. In diagonal matrix your diagonal element should be non-zero. It can be any number but it should be non-zero, and now non-diagonal element should be 0. Then we have seen identity matrix in which all the diagonal elements should be 1. Okay, and the non-diagonal element should be 0. In scalar matrix all the diagonal elements should be same, they must be equal. Next is transpose of a matrix. In transpose of the matrix, you just have to interchange the rows and the columns. Okay, means you are interchanging the first row with the first column, second row with the second column, third row with the third column. Okay, and it is denoted by A raised to capital T or A dash. Okay, so I have taken one example A matrix and we have found out the A transpose. So see the elements in the first row are 1 3 minus 5. So now they are in the first column 1 3 minus 5. Okay, second row 2 6 4 is in the second column 2 6 4. 3 8 2, it is again in the third column. Okay, so that is the transpose of the matrix. Next is upper triangular matrix. So a square matrix is said to be upper triangular matrix if all the elements below the leading diagonals are 0. Okay, so first of all see the diagonal elements. Okay, now see in the example the diagonal elements are what? 1 7 9. So that is what? Leading diagonal. Okay, and the elements below that leading diagonal are 0. Okay, and above the leading diagonal they are non-zero. So it is upper triangular matrix. Okay, in the lower triangular matrix the case is opposite, like the all the elements above the leading diagonal must be 0 and below it should be non-zero. Okay, then triangular matrix, if your matrix is upper triangular matrix or it is lower triangular matrix, that means your matrix is a triangular matrix. Okay, next is the conjugate of a matrix. Now before finding the conjugate of a matrix, let us see what is the conjugate of a number. Okay, now if you know the real numbers, yes, the whole number line we know, negative numbers, 0, positive numbers. then rational numbers, irrational numbers. These are all real numbers, right? Now if I ask you the question, tell me the square root of 4. Okay, square root of 4. So you'll give me the answer, it is plus or minus 2. In the same way, if I ask you the square root of minus 4, so what you will think first? First of all, you will tell me that we can't find the square of a negative number. Till now what you have learned, right? So to overcome this problem, complex number was introduced. Okay, and complex number was introduced. Now see what I asked you the question, root of minus 4. So first they find the root of 4, that is plus or minus 2. Then you are having root of minus 1, right? So root of minus 1 was led to be I, imaginary number. Okay, so in such way the imaginary number was also introduced. So the value of I is root of minus 1. Okay, and the number which contains I, that number is nothing but a complex number. Okay, see what was my question? Root of minus 4. That was same as root of 4 into root of minus 1. Square root of 4 we know plus or minus 2, and instead of root of minus 1 we write I. Okay, so this 2I is nothing but your complex number, and the term containing I is nothing but your imaginary number. Okay, so in this way the complex number was introduced. So usually we find the conjugate of a complex number only. If your number is real number, then its conjugate is also same only. Like your number is minus 4, so its conjugate is minus 4 only. Okay, but usually we find the conjugate of a complex number. So if a plus ib, see I have written the note above, if a plus ib is a complex number, then a minus ib is a complex conjugate. So in complex conjugate you just have to change the sign of the imaginary term. Okay, so according to that we have the next type of the matrix is conjugate of a matrix. So a matrix A is given to you, so we'll find the conjugate of the matrix A. So to find the conjugate of a matrix A, just find the conjugate of the each and every term. Okay, like first term is 2 plus I, so conjugate of 2 plus I is what? 2 minus I. Okay, we just have to change the sign of I. Second term is minus 3 plus I, so minus 3 will remain as it is, plus I will become minus I. Okay, so in this way find the conjugate of each and every term, so you'll get conjugate of a matrix A. Okay, the next is transpose conjugate of a matrix. Now transpose conjugate of a matrix means first a matrix will be given to you, then find its conjugate, then find the transpose of that conjugate matrix. Okay, see I have taken an example. Example is same. So you have given one matrix A, then I found out the conjugate of the matrix A. Then what is transpose? Transpose means just interchange the columns and rows. See, the first row elements were 2 minus I, minus 3 minus I, 5 plus I. Now they are in the first column of the transpose matrix. Okay. So transpose conjugate of a matrix is denoted by A raised to theta, and simply conjugate of a matrix is denoted by A bar. Okay.